ORC innovations, that's to try and draw people to attention that it's an innovation within the cycle, and talk to you guys out in the halls. And I'm not really trying to reinvent ORCs, but what I've invented myself and applied for patent for is a form of thermal pumping. So I'll move on to the next slide. This novel pumping process can be used on heat engines, such as organic Rankine cycles. You can utilise it for thermal expansion as an energy source to pump without shaft work or any rotating parts. You can use this for the pumping of LNG, for instance. You can save considerable amounts of energy based around the electricity you can save on running a refrigeration cycle. I've worked out that you can save 39% of the electric that you would otherwise use on a refrigeration cycle. So with regard to the ORCs, they use a working fluid feed pump, and if you look at the graph there, you'll see that the feed pump consumes more energy the lower the temperature is. And by doing away with feed pump, what you can do is make your cycle that much more efficient. So if you had, or you're desiring 100 kilowatts output, you would need to generate in the order of 109 to 117 kilowatts in order to get back your 100 kilowatts. By not having an electromechanical pump and using the heat to pump it, you can save that 9 to 17%, so your cycle becomes that much more efficient, and at low temperatures it's going to be much more efficient. Alright, with regard to fluid pumping, if you have an organic fluid such as LNG or liquid air or any other cryogenic fluid, you can expand a small portion of that in a chamber and then use that pressure to push through the fluid out past a non-return valve, and then once it's emptied, refill the chamber again with pressure at the lower temperature. So if you look at the diagram there, you've got the cold source at the top and the heat source at the bottom, and it gravity fills. With the SV2, solenoid valve 2 closed and solenoid valve 1 open, the chamber will fill. And once it's full, you then close solenoid valve 1 and open the solenoid valve 2, which will introduce the higher pressure on top of the fluid, and then gravity will overcome and it will push out through the non-return valve. There's the second one showing the vessel full. Once you've filled the chamber, you then close solenoid valve 2 and open solenoid valve 1, and then the pressure on the low pressure side will equalise and it will fill, and so the cycle continues and repeats. If you look at the diagram on the left hand side there, this is showing it for pumping of cryogenic fluids or butane. As long as you've got a heat source and the solenoid valves, you can use that instead of using a pump, the traditional electromechanical pumps with all their expensive alloys and rotating parts. This is a lot more simple and a lot more robust. It's a lot cheaper to make and will save a lot of money on initial outlay. The drawing on the right hand side is applying it to a refrigeration cycle. This has been estimated through costing to save 39% of the electric that you would otherwise use if you were using your condenser in the winter time. You can maximise what you get out of it by cycling it and getting the maximum out of your condenser in low ambience. This is the test rig that I've built at home. Initially it was this model here on the right hand side. I used actuators and ball valves there. There was more control over what was happening initially, and then I've advanced it over to the one on the left hand side there. and that's the two chambers, one filling as one draining. So, as the slide shows, we're looking for support from people who have a track record of commercialising a novel and game-changing product. This challenges traditional health benefits about pumping and harnessing useful force from temperature, and therefore a pressure range. The refrigeration application shows potential to save huge amounts of electricity over a 12-month average period. But we need to engage with manufacturers and convince them of the market potential. In the meantime, we need to maintain our IP, and staff will need to be appointed to elevate the profile of the product and keep pressure on manufacturers to incorporate our pumps through license terms and sales contracts. And that's it really. If you've got any questions, I'd like to hear them, please.
Great. Well, thanks very much, Mark. Very interesting talk. Guys, David, Andrew, like to pop any questions in?
I'll leave the questions about the technology to other people. Technology is not really our thing, like simple things. But in terms of thinking about the next 12 months, what would you say your next key hire is going to be in terms of moving the business forwards?
I think licensing is a good way for the thing. It's very simple, it's very cheap to make and install, but it's waking manufacturers up to the benefits that it has to offer. We've got to protect the IP in that period of time and hopefully negotiate with help. I mean, I'm an inventor, I've invented it, but I'm not a businessman, and that's where I'm falling short really. I'm looking for people who can help me cross that divide and get people to install it onto their systems, their refrigeration systems, their ORC systems, or in their process industries, anywhere where they can see an application and take use of it really.
Just to understand, on your refrigeration cycle example, are you replacing the compressor?
No, you keep the compressor. The problem is at the moment nobody makes a range of expander generators. If I can get market with a compressor manufacturer, they seem the obvious person to go to me. If they're making the compressor and they make the expander, they'll match them so that they work on the cycle. And that seems the logical thing to do, to make them realise there's a market. You know, you can, if you show them that with this pump, without the pump, nothing will happen. But with the pump, and then making a range of expander generators, this is potentially what you can achieve. So it's making them realise there will be a market if they apply this pump to it.
Another question?
Yeah, thank you for your presentation. Two questions. One, could you just share a little about the market or customer feedback you've had on your proposition today? Sorry.
Okay, with regard to ORCs, as these guys will vouch, because it's low temperature and it's low grade waste heat, there's Carnot efficiency comes back at you all the time. So people are always saying the scale of and the size of the components is going to make it not viable. Well, people are waking up to it more and more places are starting to use organic Rankine cycles. Now, I'm not inventing a new Rankine cycle, all I'm doing is giving them a pump to make their cycle more efficient. I would like for the manufacturers to take this on. Does that answer your question?
Thanks. Yeah, and the second one was around pumps used in a lot of different applications.
Yeah.
Could you just clarify what your first target application is and why you're focusing on that application first?
I think the oil and gas industry is a good place to focus. I've applied to what's known as the Industrial Technology Facilitator, and I'm hoping something will come of that. But I see that they circulate a lot of fluids. LNG is becoming more widely used. They're spending a lot of money on FLNG platforms, and they're moving a lot of LNG around. So I see it as somewhere to go there, because it's cheap and easy to install, and there's a lot less likelihood of it ever leaking so it makes the environment safer and it's cheaper. So that would be a good market to target, but equally I think the refrigeration one that's only recently come to me, I didn't realise this application until about 2 or 3 weeks ago, and it seems a very obvious one to me now based on the 2.8 years return. People have got to have chillers, people have got to have refrigeration, so if you install this in it, you will dramatically reduce the cost of the life cycle of the project. So if you've got to get these things, you just as well install this and save some money is what I'm thinking.
Great. Well, Mark, thanks very much. Really interesting talk. So thanks very much, and we can move on to our next speaker now.
All right, thank you.